Okay, so this is October 2021 past paper math, year 1. Okay, so first question is an integration question. Now we need to know one thing. Integration, there's a rule. So if we have x and x to the power of any number, which is we're going to say as n, the rule is going to be x power n plus 1 divided by n plus 1. For example, if we have 5x and we want to integrate 5x dx meaning in respect to x. So if it's, for example, integral of 5c dc, whatever this value is, whatever the letter is next to d is what's going to be integrated, as in يعني what is going to be considered for the integration. Now we will focus on this 5x dx. Okay, 5x dx, we want to integrate this. So we look at 5x now. We said the rule was we're gonna write 5 down as it is because 5 is a constant. X power n. Now x right now is to the power 1 because there is no power in it. 1 plus 1 is going to be 2, so x power 5x power 2 over 2. Because this is n plus 1, and just write whatever is here, you write it here. So this is this integrated. This is an indefinite integral, and the integration rule is n over x n power n plus 1 over n plus 1. Now how we can apply it on the question that we are doing? Okay, so the question that is given right now is 12x cubed plus 1 over 6 root x minus 3 over 2x power 4. First thing we need to do is break and simplify the equation that has been given. Because we need to write first the simplest form, then we integrate. So let's write the equation in simplest form. So we split this into 3 parts and simplify each. 12x cubed is already simplified as it is, so you write 12x cubed plus 1 over 6 root x. Okay, so we can say, first of all, why did I? So we can say that 1 over 6 root x is the same as 1 over 6 x, 1 over 6 times x power 1 over 2. Because x power 1 over 2 is also same as root x. A root is same as power half. So we can write, instead of root x, we can write 1 over 6 x power 1 over 2. That's the first part. Now we can do one thing. We can split this fraction into 2 parts. So we can write 1 over 6. And we can bring the x power 1 over 2 up here. I can bring it here. I can 1 over 6 x power minus 1 over 2. If I'm bringing the x power 1 over 2 to the numerator up from down to up, we have to change the sign. So it's positive, now I make it minus. So 1 over 6 x power minus 1 over 2. So we're going to write this as 12x cubed plus 1 over 6 x power minus 1 over 2. Now we look here, we want to simplify this. Now let's again split this into 2 parts. So I'm going to split 3 over 2 on its own, and x power 4. We want to take the x power 4 to the numerator up. We're going to write x power minus 4. We need to change the sign. So x power minus 4. So this is and then we just write dx. So this is the simplest form of the equation. We have to make sure the equation is in its simplest form, then we can integrate. So once we have the equation in its simplest form, then we can start to integrate. So we will integrate each part separately. 12x cubed. Now let's focus on this part, 12x cubed. So we want to integrate 12x cubed. So we need to add 1 to the power. So 12x power 4 over 4. Add 1 to the power and write whatever you get here, you will write it here. Okay, so 12x power 4 over 4 plus, we will write 1 over 6, this fraction, and we will also write a multiplying sign. I will use the multiplying as a dot, so we do not get confused between this x and the x that is here. So I will use multiply. So 1 over 6 multiplied by, so add 1 here. 1 minus 1 over 2 plus 1 is just x power 1 over 2 divided by whatever is here. So it's going to be also 1 over 2. Okay. Okay, fine. Now we're going to integrate this part. So x power, so minus 3 by 2, and we're going to put the multiplying, sign, and we're going to say x power minus 4. Okay, so x power minus 4, if we add 1, it'll be x power minus 3 over minus 3. Because if we add 1 to minus 4, it becomes minus 3. And always, when the integral in pure 1, you're always going to have to put at the end a plus c, which is a constant, plus c. So now we have everything written down. All we need to do is simplify what we have. Okay, so how we can simplify this? 12 divided by 4 is 3. So we can write this as 3x to the power 4. Okay, how we simplify this? So we can say that we can write this as... Okay, so what we can do now is we can say 1 times x to the power, we can, because I put a multiplying sign here, so 1 times x power 1 over 2 is just x power 1 over 2, and 6 times half is 3. So we're going to write x plus x power 1 over 2 over 3. Another way we can also write this is we can imagine there is a 1 over here. So what I can do is I can write 1 over 3 x power 1 over 2, which is a completely simplest form. Okay, this is the simplest form of how we write this. Now we simplify this part, minus 3 over 2, and see now, because minus 3 over 2, the minus can either be in the numerator or the denominator. And if I multiply these two, so 3 times x power minus 3 is just 3x power minus 3. But we need to imagine that because there's a minus here, I'm multiplying a minus fraction, so minus times minus will give me a plus. So we need to change the sign. Even if the minus was up or the minus was down, this makes the whole fraction have minus. So this minus times this minus will make the whole thing plus. So 3 times x power minus 3 is going to be 3x power minus 3 over 2 times 3 is 6. And we can do 3 over 6 is the same as 1 over 2. So I can write, because 3 over 6 is half, yani 3 by 6. So 1 over 2. So I can say 1 over 2 x power minus 3. And the plus c in the end. And this is the fully simplified integral. This is the final answer after it has been simplified. So be careful from the signs, and yeah, that's it. And make sure to remember the plus c in the end. Now question 2. Let's check question 2. So question 2. A curve has equation 3. This is our equation of the curve, and it says P and Q lie on the curve. So we have 2 points, P and point Q, that are on the curve, which is a curve, can be anything. It can be, it's power 5, so it can be whatever. The gradient of the curve is point P and point Q is 2. Find the x coordinates of P and Q. Okay, so it wants now for us to find the x coordinates of P and Q, and here it says we cannot use a calculator solution. So when this is written, that means we want all the working, and they do not want you to rely on the calculator. Okay, so let's start. So let's see the information that's given. It's saying that there's 2 points down the curve, and the gradient is 2. Now, whenever it gives you the gradient of the curve, the gradient of the point of the curve, and it gives you the... So let's clear out the concept now. So what is this dy by dx? You need to understand what is dy by dx. dy by dx represents the gradient of any curve, because we need to understand that when we look at a curve, let's draw a curve now. As a سبيل المثال, we have this curve, or let's make it like this. Okay, so we need to understand that a curve, it's not like a straight line. A curve, let's compare. What's the difference between a curve and a straight line? You can see that a curve at this point, for example, and at this point, the gradient is not the same. There is different gradients. But you can see on a straight line, the gradient is always the same. But on a curve, the gradient is changing. What happens is we have this dy by dx is made for us to find the gradient of curve at a certain point, because at every point on a curve, the gradient is different. So I need to understand now that dy by dx has helped us to find the gradient at a point on a curve. Now it's telling us on this curve, we have P and Q, the gradient is 2. So first thing, we need to find the gradient of any point on this curve. We need to find the dy by dx. How to find dy by dx? I will show now. So first step is to find dy by dx. Okay, so let's take an example of 5x power 2. We want to find the dy by dx of that. What will happen is, we will first of all multiply this power by this number, the coefficient. 2 times 5 will give us 10. And we will minus 1 from the power. So 2 times 5 will give us 10. And then minus 1 from the power is going to give us x power 1 or just x. So 5x squared will give us 10x. Now let's apply this to what we have. Okay, so dy by dx. So 3x power 5. 5 times 3 is 15. 15 and 5 minus 1 is 4. So 15x power 4. Plus, so understand now, 3 times 4 is 12. X minus 1 is 2. So 3 minus 1 is 2. And when we have an x on its own with a power 1, we can just do one thing. If it's written minus x, it's the same as minus 1x. All you need to do if we want to differentiate it is remove the x and just write minus 1. Just remove the x. If it was written, for example, minus 2x, just remove the x, it just be minus 2. If there is no, if the number here, if the x is the power 1. And any number by itself like this, if you want to differentiate it, it's removed, it's gone. We do not write the plus 5. It's any number that to differentiate is gone. A constant goes away. So this is okay. So this is now our dy by a differentiated equation. And after we differentiate, I already said the dy by dx means gradient of a curve. And it says the gradient of the curve. It's giving us the gradient of the curve as 2 on points P and Q. So both of the points on the curve, the gradient is 2. So what does this mean? If this is dy by dx, that means this equation is going to be equal to 2. So I'm going to write 15x power 4 plus 12x power 2 minus 1 equal to 2. And now we just solve the equation like normal people. How to solve an equation like this? It's a little difficult, that's why it's 5 marks, but no problem. So first thing we need to do is we want to bring all terms to one side, and there's literally one thing we can do is take the 2 to the side. So it becomes 15x power 4 plus 12x power 2. Well, if I bring a positive 2 to the other side, it becomes a minus 2. So a minus 1 minus 2 is going to be minus 3. And we will write equal to 0 because there is nothing on this side. Okay? So this is step number 1. We take this all to the other side. And now what we need to do is we need to factorize. How to factorize? Okay, because this is a big equation, but I think it's still possible. Because it's non-calculator, yeah, it's possible. First thing to do is we need to understand that anything, if we have an equation in the form ax squared plus bx plus c, don't get confused. A and b and c are any numbers in the world. Just think of the x squared and x, and the c is a constant, is a number. Anything in this format is a quadratic equation, okay? But the whole concept of a quadratic equation is that we need to understand that this is showing that, look, if we look at we need to pay attention to these two terms, this and this. Technically speaking, if this term, okay, is this term squared, then it is a quadratic equation. What do I mean? So whatever value to any power here, if this term is this term square, for example, if bx was, for example, bx to the power 3, x to the ax has to, for this to be a quadratic, this has to be ax to the power 6. You understand? So this squared, because x power 3 squared is x power 6. So that's what makes a quadratic. So you can see here, this term x power 4 is x power 2 squared. That means this is a quadratic equation. So we will factorize it like we are factorizing quadratic equation. Okay, first step in quadratic equation is we need to multiply this value with this value. So 15 times minus 3. 50 times minus 3 is minus 45. So we'll put down here minus 45. And we need now two numbers that we multiply, they give us minus 45. They add, they give us positive 12. Okay, let's write down the factors. We have 1 and 45. We have 2 doesn't go. If we divide by 3, we have 3 and 15. Yeah, 3 and 15. But it's going to be plus 50, positive 15 minus 3. So positive 15 and minus 3. These are the two values because plus 15 minus 3 is positive 12 and plus 15 times minus 3 is minus 45. Okay, so now let's rewrite this equation. Instead of writing plus 12, we're going to x squared. We're going to write 15x to the power 4. And we're going to write plus 15x squared. Whatever it's here, we're going to use. Since this is x squared, we will use this as x squared. Plus 15x squared minus 3x squared. And this is a minus 3, so alright, minus 3 equal to 0. And now we factorize. So we need to split this into two parts. First, we factorize this. So what is common here? A 15 and an x squared. So 15x squared is common. And we will put a bracket. We will write x squared and plus 1. Because this is factorizing. 15 times 15x squared times x squared is going to x to the power 4. 15x to the power 4. And 15, this is the same as this. So I'll just write plus 1 because 15x squared times 1 is this 15x squared. And we go and move to the other side. This is a minus sign, so minus. What's common here? The only thing common between this and this is going to be a 3. And it's going to be x squared. We can't put minus because if I put a minus, it's going to be minus times minus will make this plus. But this is not plus, this is a minus 3. So I'll put plus, again 1, equal to 0. And how do we know this is correct? We know this is correct because this and this is the same. This shows that our equation is correct. And now finally what we will do is we will combine these two, 15x squared and minus 3. So I'll write 15x squared minus 3 and x squared plus 1 equals 0. Okay, equal to 0. How this will work? Okay, so we know that. Let's rewrite. Let's split this into two parts again. So we know that 15x squared minus 3 equals 0. So we want to get x subject. We want to find x. First, we take the minus 3 to the other side. So it will be 15x squared equal 3. We want to get rid of the 15, so we divide 15 both sides. So x squared, so 3 divided by 15 on the calculator is going to be 1 over 5. And, okay, so since this is x squared, the opposite of x squared is root. So I will root both sides. Root here and root here to get x. So x equal to root 1 over 5. I don't need to write the exact, I don't know the value, but I will write root 1 over 5 because that is correct. Or if you put it in the calculator, you will get x equal root 5 over 5, which is also a correct answer. Both are correct as long as they represent the same thing. Root 1 over 5. Now we move on to this part. X squared plus by the way, don't forget because we are rooting anything will give us plus minus 1 over 5. So we have x equal to plus minus 1 over 5. That's two coordinates, by the way. X equal to plus root 1 over 5 and x equal to minus root 1 over 5. So we need to let's write this as our answer because this is one of our answers. Root plus minus 1 over 5. Let me put a square around it. And we have our second part, which is going to be x squared plus 1 equal to 0. Now, if we take this other side, it becomes x squared equal to minus 1. But if I root both sides now, this is not possible because I cannot get the root of a negative number. So this is not possible. So we only have one answer or two answers here, which is x equal to plus minus root 1 over 5. And that is our final answer to give us all the 5 marks, inshallah. Okay, moving on. Question number 3. 3 over x is greater than 4. Okay, so here it is giving us this equation. This looks very easy. It looks easy, but it might not be that easy. It's not as simple as it seems. Okay, so let's solve it here. So we need to understand, first of all, is this: we do not want anything in the denominator. But the trick here is, if I multiply both sides by x, it will be 3 less than 4x. And it will be 4x less than 3. But, sorry, if I take this other side, 4x minus 3 less than 0. But see, this is not gonna work, because this does not give us the full range of values. To solve this equation, I need to first of all get rid of the denominator, and also I need to make this into a quadratic. Easiest way to make this to quadratic is to multiply the whole equation, everything, by x squared. If I multiply the whole equation by x squared, I will get, because 3 times x is just this, so if I get x squared and multiply this equation, I will get 3x greater than 4. Okay? Now I'll take all the 4x squared, sorry, because I'm multiplying this with also 4x squared. So 4 times x squared times 4 is 4x squared. So I will take all to one side. Now I will take 3x to this side, so it will be 4x squared, and this will be positive, it will become minus. So minus 3x is less than 0. Okay. Now this is again a quadratic equation. How we will solve? Well, because there is no constant of the quadratic equation, first thing we need to do is we need to take the x, because they are both common. X is common in both. So we can factorize x outside, because we can take x outside, and we can do 4x minus 3 is less than 0. Because x times 4x is 4x squared, and x times minus 3 is minus 3x, less than 0. Now, we need to split these two into 2 parts. Okay? So we have, and if we are splitting these two, we have this rule usually, is that one of them will be greater than this, and one of them will be less. In this case, this x will be greater than 0. We need to flip this. And this thingy will be, I'll show you what I mean, okay? Wait. Let's not get into complicated stuff. Let's split this into 2 parts first, and let's focus on the 4x minus 3. So 4x minus 3 is less than 0, okay? I take the 3 to the other side, it becomes 4x less than 3. And then divide both sides by 4, and I get x less than 3 by 4. Okay, so that is our first coordinate. So let's write our answer, but we're not done. Remember, I told the first thing, if this is less than 3 by 4, okay, it's less than 3 by 4, but because I split this into 2 parts, this is less than, and this one will become greater than. So x will be greater than 0. Because, like, imagine I didn't have this part, this will flip. So it will be x greater than 0. So how I will write it? I'll write my answer like 0 less than x, so x is greater than 0. And x is less than, which we use the second part of the equation, this one, x less than 3 over 4. And this is how we got our answer. I hope this is not too confusing, but this is our answer. Okay, so we'll go to B now. B, it's giving us a graph, a quadratic. So let me delete this part, because it's not distracting. Okay, so we have here graphs, or no, it's just two graphs. So we have a quadratic, positive quadratic, and we have a linear, which is a straight line. So these are the two curves. Now we know that there is this region R, which is, as you can see, it is shaded. Yeah. So this region R is shaded, and it lies in coordinates 2 and 3, and is bounded by C and L only. Okay. Given that L has a gradient of 3, so the line L here, it has a gradient of 3. So we know it's gradient of 3, and this is a straight line. Any straight line has an equation of y equal mx plus c, where M is the gradient and C is the y-intercept. Fine, fine. Okay. And C has the equation, which is the curve C, this one. 2x minus 50 squared minus 50. And C and L intersect on the negative x-axis. Okay. So we know that this L and this C intersect on this point on the negative x-axis. Okay, so we need to understand one thing. This quadratic graph intersects at 2 points. Forget the straight line for a second. We know that the quadratic graph intersects at this point and intersects at this point. Intersects with what? Intersects with the x-axis. You can see the x-axis. The quadratic graph touches the x-axis here and it touches it here. But you see where it touches it here, the line is also coming through. So the line is also coming to that same point which the graph touches the x-axis. So that will help us with one thing. I will show with what. First thing we need to know is we need to find the point, this one, where L and C intersect, because if it wants us to use inequalities to define the region R. So we need to use inequalities to find this region, this place. What is making this region? Inequalities. So I will show what I mean in a second. But first of all, we need to find this point of intersection. And the easiest way to do it is we need to look at our quadratic graph. And we know that it touches the x-axis. And if I want to find the x-axis crossing point, we have to make y equal to 0. But 2x squared minus 50 equals 0. Okay? And I can take the 50 to the other side. It becomes 2x squared equal 50. Then divide both sides. X squared equal 25. So x equal to, we root both sides, plus minus 5. And it says they intersect at the negative x-axis. Negative x-axis means our value that we're going to be using for the intersection is going to be is going to be minus 5. Okay, so we need to understand that C and L intersect at the point minus 5 and 0, because 0, the y-axis and the x-axis, y equal to 0. Okay, so we have that. Now, to define the region, we know that the region R, we need to look at the region R. What is the lines that's like the region is bound? What are the boundary of the line? We know, you see this boundary that's of the region R. This is one of the boundaries, and this line here, line L. Now, how we will know what region R is? We need to define it, and we define it using the inequalities of these boundaries. So it's like if region R is greater than this line or it's less than this line, and I'll show what I mean in a second. But before then, we need to find the equation of this line L, so we can use it as an inequality. Line L. How to find line L? Well, I said before, well, you need a gradient. I said before, the equation of a line is y equal to mx plus c. So we need to write, and it says here line L gradient is 3. So let's write y equal to 3, which is the gradient x plus c. What is missing in our line equation is going to be the c. How to find c? Well, as you can see, we found one of the points here where c and L intersect. We found one of the points of L. So we can use this point and we can substitute minus 5, which is the x coordinate, as x here, and we can put 0 as the y. So let's do that. 0, which is y, is going to be equal to 3x, we substitute minus 5, plus c. Okay, 3 times minus 5 is minus 15, so it's equal to minus 15 plus c. And I will take the minus 15 to the other side. It will be c equal to 15. So we found the value of the y-intercept c. Meaning the equation of the line is going to be y equal to 3x plus 15. This is line L, which is this line, the straight line. Now we need to define you need to actually solve the question, which is to use the inequalities to define the region R. Okay, as you can see, we need to focus, when we are looking at inequalities, we need to focus at the boundary of everything. Looking at this boundary, as you can see, this boundary, we look at the quadratic curve. You see the quadratic curve, it is bounding the region R, the shaded one. Now, how to know what to write as the inequality? We know the equation of the line is 2x squared minus 50. Now, what I write is, since the line here, you can see that the y coordinate of the r, like the shaded region, the y is always going to be less than the curve y. See, if I continue zigzagging down here, okay, from the point where region R is, I am going to eventually end up where below the graph and not above it here. If it is above it, then y is going to be greater than 2x squared minus 50. But because I am below it, see how I'm below it? The graph here is going to be above, here is going to be below. Because if I go here, I'm going to eventually end up below the graph. If my r was here, for example, I'm going to end up above the graph here, see? That'll be y is greater than. But now, since we're below the graph, this first inequality is going to be y is less than or equal to, y less than or equal to. If the line is a solid line like this, it is going to be less than or equal to. If it looked like a shaded line like this, or a dotted, sorry, it's going to be only less than, not less than equal to. But because it's dotted, so we're going to do y less than equal to 2x squared minus 50. First inequality, and we can put a box because it's the answer. Second inequality is going to be this boundary of this line. Well, this boundary of this line, we already found the equation, and we know because, again, this region R, as you can see, is above the line. Here it's below, here it's above. You can see above line L. That means y is going to be greater than 3x plus 15. Because we're above the line L. Y greater than equal to, because I said it's shaded. Just a solid line. 15. So this is another inequality. But you also need to understand a trick that Edexcel uses is 99% of the times they're also going to look for one more key crucial thing. We need to look at this specific point here. You see where the two lines intersect. We know that the region R is to the left of this specific point. So, and if we are to the left, if we're moving to the left, the value of x decreases. So we have to say, and we know already this point is minus 5. So we can say, as we're moving to the left, we can say another inequality is x is less than minus 5. These are three inequalities. These are our three inequalities. Okay, so that is 3 inequalities done. And this is question 4. How many questions in this paper? Allahu Akbar. There's 10 questions, no problem, easy. 10 questions, very simple. Okay, so question number 4 now is a sketch the equation y equal f(x), where f(x) equal to cos 2 of x. Now we need to understand something in, we need to first look at trigonometric graphs. So if we open a whiteboard, which is better than if you can open a whiteboard, I'll show exactly what I'm talking about. So when we look at trigonometric graphs, which is trigonometric as I mean sine graph, we have 3 trigonometric graphs: sine, cos, tan. When we look at the sine graph, we need to understand that, let's draw a sine graph. A simple, this is just a sketch of it, not full accuracy. But there are just the important things that you need to know is, a sketch would look like a wave like this. Okay, so we need to understand that each, or not each, but we need to understand when the graph reaches here, this is a 90 degrees. Here it's 180 degrees. Here it's 270 degrees. And here it's 360 degrees, and this is one complete cycle. This is one complete cycle. I mean, it's going to keep repeating the same thing over and over again. And this is one cycle, and everything you see here, you're adding 90, adding 90, adding 90, adding 90 degrees. Also, when you're writing the coordinates, don't put the degree sign. Just write it 90, 0, for example, or whatever. The thing is, this is a sine graph. This is a sine graph. We start like this, up 90 degrees, come back down 180 degrees, 270, 360. Now this is if it were in degrees. If we want to do it in radians, it's the same thing. Here 90 degrees is the same as pi over 2 because we know pi equal to 180 degrees. So half of pi is 90 degrees. Pi is 180 degrees. 2 pi is a whole circle and it's 60 degrees. And we know that pi over 2 equal to 90 degrees. So this is pi over 2. 180 degrees is going to be pi. And 270 is going to be 3 pi by 2. And 360, which is a one full period, we also call a full cycle, a full period, يعني. A full cycle is 2 pi. And this is the graph. And if we go on this area, it's the same thing but negative. Same thing but the negative. So it's going to be like this, and this is going to be minus 90 degrees, this is going to be minus 180, and so on and so forth. This is if we had the graph y equal to sine x. Also, we need to understand that if we have a number, like for example, let's say we had sine x, but instead of a 1, it'll be sine 2x. In sine, if the normal sine x, where this is no number here, we know that the maximum point here is 1, and the minimum point here is minus 1. If it was sine 2x, then this would be minus 2, and this would be 2. If it was sine 3x, it would be minus 3, and this would be 3, and so on. It just works like that. Now let's go to the cos graph. So we have cos x, y equal to cos x. So let's draw that. Cos is a little different. It starts up, comes down, and comes back up like this. Now we need to know that this is here it is 90 degrees at this point. At this point we are at 180 degrees, which is pi, and here it's pi by 2. Here we are at 270 degrees, which at this point, which is 3 pi over 2, and this is the final point, which is 2 pi or 360 degrees. And again, this is at 1, and this minimum is minus 1. This is 0. And again, if the same concept, if it was written 3 cos x, for example, this would be minus 3, and this would be 3. And the last graph we need to speak of is going to be the tan graph. The tan graph is the most different graph on planet Earth. Tan graph, well, we need to understand something called an asymptote. So look, asymptotes are points on the graph where the line will never, it will get close, but it will never touch. So we will draw the asymptotes of tan. I will show the asymptotes of tan. The dotted lines are the asymptotes. So how to draw the graph? First of all, there are an asymptote. An asymptote is basically a line or like a dot, this part of a graph where the line is going to go very close but never actually touch it. How the tan graph will come is, there is going to be asymptote every 180 degrees. So the starting asymptote is at 90 degrees here, and the end is at 90. And then you add 180, and then it will be here 270. 270 plus 180 is, and so on. You need to add 180. But we start at minus 90 is one asymptote, and 90 degrees is another asymptote. Also 90 is also same as minus pi over 2. And here we have pi over 2. So we will draw a line coming like this. It will come here, cross to the center. And it will come to this area. And it will get close to it. But wait, hold on. It will come close to it, but it will not touch it. Something like this. Okay? And this whole area that the graph is occupying is worth 180 degrees. That means that then the distance from this asymptote to the next asymptote is also 180 degrees. So let's say this is a 270, because 90 plus 180 is 270. Again, same thing. There's going to be an asymptote here. And we're going to draw a line like this, and it's going to keep going, you know? It's going to keep going every 180 degrees. But understand that this is the concept of a tan graph. Now, here we have a little different equation, a little different thingy. Understand that if we're looking at a y equal to cos x, but instead of 2 cos x, the change is happening in x, cos 2x. The change is in the bracket. And if the change is in the bracket, that means we have a stretch. What do I mean by that? Okay, let's imagine this was the normal cos x graph. We know, and by the way, this is in degrees, so we're gonna use degrees here. If it says in radians, we would use radians. This is 90 degrees, we said. This point. This point is 180 degrees, we said. This point, in a normal, by the way, normal cos x, not in this one. I will show what I mean. And this is going to be 360 degrees. So we need to understand now that in a cos graph, that if this is 2x, well, whatever is, we need to multiply the x coordinates by the reciprocal of 2. Reciprocal means we know 2 over 1, 2 is the same as 2 over 1, we'll just flip it. It becomes 1 over 2. So I need to multiply all the coordinates of x by 1 over 2. So I multiply, so how will that change everything? How that will change it is, well, now instead of the normal stuff we have, it changes things. Cos is a graph of cos 2x. We said this was 90 degrees before, but now we need to multiply it by 1 over 2. 90 times 1 over 2 is going to be 45 degrees. Here it used to be 180 degrees, but now we multiply by 1 over 2, so it's going to be 90 degrees. Here it was before 270 degrees, but we need to divide that, multiply by 1 over 2, which is 104, no, 270 is just 135. And the full period here was 360, but now since we divide by 2, it is 180. This is our cos graph. And as you can see, the distance from here to here, we added 45 degrees. So that means the distance from here to here, because there's a repeating cycle, is going to be at 45 degrees to find r if we need it. So now it wants us to find the coordinates of q. Q, okay. So how to find the coordinates of q? So how to find the coordinates of q, we need to look at here. We already showed that this is 90 degrees. And we know in a cos x graph where this is 1, we know that the minimum is minus 1 and the maximum is 1. So here is going to be 90 minus 1. So q is 90 minus 1. Don't write the degrees sign. It's degrees, but don't use the sign. And the value of k. Value of k here, where is this value of k? Value of k is here, which is showing us, first of all, this is an inequality showing us how big the graph is. What is the numbers that the graph is showing us. So it says here 0, so the graph is starting at 0 and it's ending at k. So k is basically this point in the x coordinate of this point. I said to find the x coordinate of r, which is k also, we can say, we add 45 from here. So 180 plus 45 on the calculator, which I can do 180 plus 45. It's going to be 225. So k is 225. By the way, don't write my answers like me. Write it always on the lines below, but I am only doing this so I can save time. Now it says, given that there are exactly two solutions to the equation, cos 2x equal to p in the region 0 greater less than equal to x less than equal to k, find the range of possible values for p. Okay, exactly two solutions. Well, two solutions to the p. P can, I'll show you what I mean by this. No, actually keep these. It says we have exactly two solutions in this equation, cos x equal to p. P can be any number, but p represents a line that looks like this. Any line that's a parallel to the x-axis, like a straight, like this. Now it says we have two solutions. What are the possibilities of us having two solutions? Okay, understand one thing. If we have two solutions, that means the graph is going to do like this. It's going to cut the graph at 2 points. 1, 2. This means two solutions. Now, where do we have our two solutions? We need to analyze this. If I draw a line like this, we have 1, 2, 3 solutions, which is not what we want. If I draw a line on the top where y is 1, then I have 1 and 2 solutions, one here and one here. So first thing we can do is we can say P equal 1 for B, P equal 1. And also, if you look below the x-axis here, we have 1, 2. But be careful, because if I draw a line here, it's going to give me only 1. So it has to be in between this part, but less than this. So what I will write is, this is 0 and this is minus 1. So I will write 0 less than equal to P less than equal to minus 1. And here you go, is our two inequalities. خلاص now. This is the trigonometric graph part completely over. Hope it is easy. Now we have the next question. This is the lines. These are lines. Question on lines. Then we have what else? 6, 7. It's trigonometry. Okay, fine. Let's continue this paper. So we need to understand now. This is a question. It gives us the line L1 has the equation. This equation. The line L2 passes to this point and it's perpendicular to L1. And line L1 and L2 meet at point P, and find using algebra the point working the coordinates of P. Okay, this is going to be a little bit of a long one, but it is easy as well. So let's look at this question. The line L1 has the okay. So first thing we gotta do is we look at an equation like this. Okay, line L1 has this equation, but you can see that there's something wrong with this equation. You can see that this equation, well, y is not the subject, because you know an equation of a straight line is y equal to mx plus c, where y is our subject. So first thing to do is make y subject. In order to make y subject, we take the minus 2x and put it to the other side. It becomes 3y equal to positive 2x plus 30. And I want the y to be on its own, so I divide all sides by 3. It becomes y equal to 2 over 3x plus, because 30 divided by 3 is 10. So our first equation is y equal to 2 over 3x plus 10. Okay, this is our first equation. And we know that line L2 passes to the point A and is perpendicular to L. Okay, so how to find line L2 equation? First thing, we know that they are intersecting. We need to find P. P is where the two L1 and L2 intersect. And if we are finding the intersection, we need to make the two lines equal. But I don't have equation for L2, so I need to get the equation for L2. We have L1, which is this. This is our equation for L1. It's a very simple and easy to get equation. So now what we do is, now we have to find L2. It's telling us L2 is perpendicular to L1. To find, so L2 perpendicular, meaning to find L2's gradient, I will flip the fraction and I will change the sign. So it will be minus 3 over 2, which is going to be our gradient for the perpendicular line. So y equal to minus 3 over 2x plus c. And we should find c. We have the points we can substitute. We have x is 24 and y is 0. So we can say y equal to minus 3 over 2, 24 plus c, and y is 0. So I write 0 here. Okay. So we can put this in the calculator, and minus 3 over 2 times 24 equal to minus 36. And we want to make c subject, so c equal to 36. So the equation of the line will be y equal to minus 3 over 2 plus 36. Y plus 36, because minus 3 times minus 24 will give us y equal to y equal to 0 equal to minus 36 plus c, and I want to make c subject, so I take 36 to the other side. I get positive 36. So c equals to, or 0 equal to, or ya Rabbi, y equal to minus 3 over 2 x plus 36. And this is our second line equation. Now we have to find point P where they both intersect. So what I'm going to do is شو يسمونه. I'm going to equate the two glass L1 and this is L2. So I'm going to make them both equal. So I'm going to write 2 over 3x plus 10 is equal to the other line, which is this one, minus 3 by 2x plus 36. And now very easy thing to do. I will just take the like terms together, so I'll bring this to this side where the x is, and I'll bring this to this side. So I'll just add this now. It becomes positive because it's negative. So 2 over 3x plus 3 over 2, 2 over 3 plus 3 over 2 on the calculator will give us 13 by 6. 13 by 6 x equal, because I'm adding 2 by 3 and plus 3 by 2, because the minus becomes a plus when I take it here, and I put the plus 10, it becomes a minus 10 here if I take it to the other side. So 36 minus 10 is 26. So x equal, I can divide both sides by the whole thing, 13 by 6. This will give us x equal to 12. Okay, so our x coordinate of the point of intersection is 12. Now to find the y coordinate of the point of intersection, we need to substitute this 12 into any of the two equations, either this one or this one, same thing. I will substitute it into this one. So I will, to find the y equal 2 over 3 12 plus 10. So 2 over 3 times 12 plus 10, let's give it 18. So our p is going to be x-axis 12 and y-axis 18. So p equal 12, 18. And that is our answer. 5 marks. Okay, what does B want? B says, figure that L1 means the x-axis at point B. Okay, so find the area of the triangle BPA. So first of all, let's imagine this in our heads and draw a graph to visualize what we're about to witness. So if I draw a graph, mini graph, sketch of anything of what we have. Okay, so we have the line L1, which L2, sorry, L2 passes to the point 24, 0 and is perpendicular to L1. 24, 0 is around here, it's far. So let's say it's draw this سبيل المثال, we'll have it here. And we have P, which is the point of intersection, 12, 18, which is about here. Okay, and then also we have, it says one more thing it gave. It gave that L1 meets the x-axis at point B. Now to find where L1 meets x-axis, we need to make y equal to 0, because x-axis, y equals 0. So the L1 equation is this. So if I did 2 by 3x plus 10 then equals 0, I will take 10 to the other side, be 2 by 3x minus equal to minus 10, and divide both sides by 2 by 3, you will get the calculator, you will get the answer of minus 15. So you will have a point here, minus 15. Okay, خلاص, so we know all the points we have, so we can connect the dots. Have a point here, this is the line L1, and you can see this is the line L2, and this is the point of where they intersect. This is the point P. We said P was going to be this one, 12, 18, so this is 12, and this is 18. 18 is going to be our height, see? Because this is 0, and this is 18, so our height between this point and this point is what? 18. So our height of the triangle is 18. And to find the base of the triangle, we know that this is minus 15 and this is 24. Yeah, because it says the line L2 passes to the point A, 24. And we know this is the point A, this is the point B, and this is the point, this is the point B, and this is the point P. BPA. So the area of a triangle is area equal of a right, because you can see if I draw a line up down here, it forms a right angle, so I can use the formula area equal to half base times height. Base is going to be this distance, So I can do, we have to do delta, so this minus this. So 24 minus minus 15. 24 minus minus 15 is going to be 39. So our base, this distance here, is 39 units. So we're going to do area equal half 39, height I told you 18. It's going to give us the value 351. Okay, this is our answer. Unit squared, you can say, because there's no unit given. So you can just do that. So as you can see, this is our answer, and this is how we found it. If you want, a good idea is to actually visualize it by drawing a graph like this, because it will help a lot in seeing exactly what I'm trying to do here. So I found P, yes, I equal. Why do I equal the two lines? Because they both meet at this point. That's why I equal them to find the point of intersection. And that's how it is. So this is our thing. And this is our drawing, kind of. And yeah, that's all the marks we get for that question. And even in the actual exam, you can draw. They don't mind. Okay, so as you can see here, it says a curve C has equation y equal to f of x, where this is our equation. Now, first thing to do, we need to sketch a graph of C. How to sketch a graph of C? Okay, understand that this graph is squared, by the way, means this. X minus 3 squared is the same as that. X minus 3, x minus 3, and x plus 1. Okay, sketching the graph. So let's sketch this graph and see how it goes out. Okay, so how to sketch this graph? Well, first of all, it says it wants us to sketch the graph showing all the coordinates of the point where C cuts or meets the coordinate axis. Means every time it cuts the x or y axis, it wants to know the point at which it does. First of all, you know that it's a cubic, and it's a positive cubic graph, because you see here, it's, if I multiply x times x times x, I get x cubed. So this is an x cubed graph. And we know that there's 2 points at here. To find the points where it crosses the x-axis, we do one thing. We take this sign and we flip it. So plus 1, it means it crosses at minus 1, and it crosses at x equal to 3, because I flipped the sign. But here it doesn't cross, it touches. If I have a squared, I'll show you what I mean by touches. But it means we know that it touches 2 points, x minus 1 and x equal to 3. So how we draw this? So we know that, and we also need to find the y-intercept. Y-intercept is we make x equal to 0. So I can write as 2, 0 plus 1, 0 minus 3 squared. Put this in the calculator, you get the y-intercept, which basically means where the line crosses y. So 0 plus 1, 0 minus 3 squared. We get 18. So the line will cross at 18, the x-axis. How to draw? Well, we know the points it will cut. It will touch at minus 1, we said, and to touch at 3, and to touch at here 18. So to draw, we will draw this line, and I will not, it's not going to be the most accurate, but I'll draw a line like this, and I will take my pen, come here, and it's going to come like this, and it's going to touch it like this, and it's going to come back up. Why like this? Because it's x minus, why it's touching and not crossing? Because it's x minus 3, x minus 3. So this basically means x minus 3 squared. So that means there's no other point. If it goes down, it's going to have to touch another point. But here it's only coming 3. So we're just going to touch and come back up. And this is how to sketch the graph. And we need to write all the points down where it touches. Write the points. So we have to write them. Minus 1, 0, 0, 18, and here is 3, 0. Okay, this is just very simple. Okay, that's it. Now, it says here, write effects in the form ax cubed plus bx squared plus cx plus d, where abc is dx. This basically means expand this. That's it. So let's write it down and expand. It's very easy to expand. We just need to use our expanding skills. 2x plus 1, and it's x minus 3 squared, yeah? X minus 3 squared. Okay, understand to expand this equation. First thing is we want to expand this part, because it's squared. So let's expand it. X minus 3, x minus 3. Very simple. X times x, x squared. X times minus 3 is minus 3x. 3, and then minus x again, it will be minus 6x. And minus 3 times minus 3 is plus 9. So x squared minus 6x plus 9. Okay, this is our answer. So this is our answer for this expansion, and we can expand this also. 2 times x is 2x. So let's write that down immediately to not wasting time. And 2 times 1 is 2, so plus 2. And we write this, instead of x minus 3, we can write this thing. X squared minus 6x minus 9. Okay, now we expand this. 2x times x squared is going to be 2x cubed. 2x minus 6x is minus 12x squared. And 2x, 2x, so this is 2x, yeah, 2x. 2x plus times plus 9 is going to be plus 18x. And I extend with this one. 2 times x squared, positive x squared is going to be positive 2x squared. Okay. 2 times, 2 times minus 6x going to be minus 12x. And 2 times 9 is plus 18. So this is it expanded. Now we just simplify, add like terms. 2x cubed is on its own. Like term minus 12. Okay, so we have minus 12x squared plus 2x squared. So minus 12 plus 2 is going to be minus 10. So minus 10x squared. 18 minus 12. So 18 minus 12 is minus. So plus 6x plus 18. So this is our answer. Fully expanded. Expansion is very easy. Just do the thing, you know. This is called the FOIL method, يعني. Expand. It's very simple to expand. Okay, so this is the expanded version. Now it says here, and find the equation of the tangent. Oh, this is a problem. Well, not really a problem, but find the equation of a tangent at C, where x equal to 1 over 3. Tangent at C. So we have, this is the equation C. Now tangent can be anywhere, but it says tangent at C where the point equal to x, when x equal to 1 over 3. So let's say, I'd say around here. This is what, this is the line that's going to look like. The tangent is going to look like this. Something like this. Touching apart. Now again, a line needs to have a gradient and a y-intercept and the point. It gives us an x coordinate. Okay. To find the y coordinate, we will just substitute this value into x, but as x here. But before that, before I do that, let us first find the gradient of the tangent. How to find the gradient of the tangent? Well, we said to find a gradient of a point on a curve, we first need to differentiate. Because now we are dealing with a curve and not a straight line. And we don't have a point. If we had a point on the tangent, have a point here, then okay, but we don't. There are no points on the tangent. So we have to use dy by dx. And we need to differentiate this. So to differentiate this, we need to, again, we need to use the rule. Power time, okay, so 3 times 2 is 6. And minus 1 is 2. 3 minus 1 is 2. 3 times 2 is 6. And x power 3 minus 1 is x power 2. 2 times 10 is minus 20. And 2 minus 1 is x power 1 or just x. This I told you just remove the x, so plus 6, and this goes away. This is our differentiated equation. And this is how we're going to get the gradient. Now to find the gradient of the tangent, I'm only going to substitute x with 1 over 3. So 6, 1 over 3 squared minus 20, 1 over 3 plus 6 is going to give us the gradient of the tangent. This is going to be exactly a value of 0. So the gradient of the tangent is 0. Now what does this mean after I put this in the calculator? Now what does this mean? Is our tangent is not going to look like I drew it. It's going to look more like this. Straight line. Meaning there is no slope to it. But yeah. So all we have to do is one more thing. All we need to do is substitute this x coordinate 1 over 3 because there's no gradient. So we just need to do one more thing. This x 1 over 3 we substitute it here. And if I substitute it here, if I substitute in this equation, so 2, I can substitute this equation also, this is the same one. 1 by 3 cubed minus 10, 1 by 3 squared plus 6, 1 over 3 plus 18, and this is going to give us y equal. So if I substitute it, let's see what the answer will be. The answer will be 512 over 27. This is after I substituted it. And since the gradient is 0, I don't need to write plus 0x because that's not a thing. So I will just write this is our answer. And this is the final answer for question 5. Okay, so this is question 7. So question 7 is trigonometry. Now in trigonometry, before I start, we need to explain some concept. Trigonometry, there is two things. There is something called a right angle triangle and there is a non-right angle triangle. If we are looking at a right angle triangle, which is a triangle with a right angle like this one, there is a rule. Okay, we know that let's say for example this side is C, this side is A, and this side is B. To find C, the formula is Pythagoras theorem. C here, so C square equal A square plus B square. This is Pythagoras to find this side C. Okay, we know the sum of angles in a triangle is 180 degrees. Now we also know that if we want to, let's take this angle for example. Let's say this is theta. This is our angle, this one. The longest side, which is C by the way, C, the longest side C is our what we call the hypotenuse. Hypotenuse, and the shortest side, or not the shortest side, sorry, the side that is opposite to the angle, which is this one. In this case, يعني this one, it's called the opposite side. And the one that is next to it, which is this one, not the hypotenuse, the one next to it, it's called the adjacent side. So there are rules. Sine theta is equal, if you want to find the sine of theta, to find this angle, sine theta is opposite over hypotenuse. Opposite side, opposite, which is this side, over hypotenuse, which is this side. Sine theta. Cos theta, adjacent over opposite, adjacent over hypotenuse. Adjacent, which is this side for this angle, and hypotenuse, which is this side. And tan theta, oh my god, equal adjacent over opposite. Now you're telling me what I will use this for. Imagine I have a triangle and I have this side and I have this side and I want to find this angle. Well, what I will use to find this angle? This angle, I have the hypotenuse and I have the adjacent. Which one I can use? I'm gonna use cos theta because cos theta is adjacent over hypotenuse. I can't use sine theta because I don't have the opposite angle. Opposite side. And I can't use tan because I don't have the opposite side. But I can use cos. So you can say cos theta equal to adjacent, adjacent is 4 over hypotenuse, which is 7. And to find the angle, you're going to do something called cos inverse. 4 over 7. Or, in A-level term, we call it arc cos or arc cos, which is the same as cos inverse. Or sine inverse is same as arc sine. tan inverse, same as writing arctan. So you can use anything you want. You can write this, you can write this. This looks more fancy, that's it. As long as you do it. So cos inverse 4 over 7 will give you the angle x. If you put it in the calculator يعني. Okay, now we look at the other part where we have a not right angle triangle. We have a triangle like this, for example, but I will make it wider, yeah, like this, where this side is A, this side is B, and this side is C, and this angle is A, this angle is B, and this angle is C. Okay, so understand one thing. Also, first, so let's go back to the right angle triangle, by the way. Right angle triangle, the area is equal to half base times height. That's only in the right angle. Here, it's different. Here, we cannot use sine equal to opposite over hypotenuse. Okay? Here, we have to use something called the cosine rule. Cosine rule is a square equal b square plus c square minus 2bc cos of a. Now, this is basically if, for example, I have a triangle, and I have this side which is 5 centimeters, and I have this side which is 6 centimeters, and I have the angle in between them, which is, let's say, 107 degrees. If I have the two sides and the angle in between them, I can find this x using this formula, a squared equals b squared plus c squared, where this is going to be RA and this is going to be RB and this is going to be RC. A is always the one we want to find, okay, in a non-right angle triangle. So to find it, I'll use this rule and I'll just substitute. So a square, we know the rule is a square equals b square plus c square minus 2bc cos a. That we will do a equal, because squared, if I want to do opposite square, I'll do root. So 5 squared plus 6 squared minus 2bc, b is 5, c 6, and cos of a, cos is the angle in between, so this one, just cos 107. You put this in the calculator, you get this angle. And it works not only for this side, it also works if I have a triangle, for example, another triangle, and I have, for example, this side, and I have this side, and I have this angle. I can use that to find this side. Same substitution, same method. Just using the formula, the cosine rule, a square equals b squared plus c squared minus 2bc cos a. Okay, so that's that. Then that's called the cosine rule. Now we also need to talk about the other rule. Other rule is going to be the sine rule. The sine rule is a over sine a equal b over sine b equals c over sine c. This meaning a over this angle a, which is its opposite, is equal to b over this angle b, which is its opposite, equal to c over this angle c. Now tell me, how the hell is this useful? I'll tell you how this is useful. Let's say, for example, we have this side, which is, let's say I have a triangle. Triangle, which is, this side is 7 centimeters, this side is x, and this side is, say, 40 degrees. This side, we know the angle, which is, let's say, 37 degrees. But we don't know the side. We want to find side x. But now we can use the sine and cosine rule. So we know that a, which is 7, over opposite angle, which is sine 40, equal b, which is x, over sine 37. And we can rearrange to make x a subject. Literally, that's it. So to make x subject, I will cross multiply. So sine 40x equal to sine 37 times 7. And x is divided both sides by sine 40 to get rid of them. So you get sine 37 times 7 over sine 40. And this is how we use the sine rule. So this is sine rule, and this is cosine rule, and this is all the rules. Now we have one more thing. We have area equal to half AB sine C. Very simple. If we have a triangle, and we have two sides, which is, for example, I have 6 and I have 10, and I have the angle in between them, which is, let's say, it's a 40-degree angle. We can use this. So as long as we have any two sides, this and this and this, but as long as the two sides and there's an angle between them, I can substitute. Let's take this is A and this is B, and this is going to be sine C. So half the area of this triangle will be half 6 10 sine 40, which is this one. And this is our answer, whatever we get on the calculator. This is how to find the area. Now this is all done with triangles. Now we move on to one more thing. We have circles. Circles, we have something called a radius, which is something from the center of the circle to the circumference. If I have two radius anywhere on the circle, the radiuses are equal. Okay. Now, understand one thing about something in circles. So circles, thing about circles is radius is always equal. So this is 5, this is 5, and if this is also, if I have this is also 5. So anything from the center to the circumference, they're always equal. To find the length, so for example, let's say I have this angle, which is in radians. I'm going to use 0.7 radians, and I want to find this length. Well, or I want to find the length, sorry, of this one, this part. I want to find the length of this arc. So what I will do is I will use the formula L equal to r theta, where r is the radius. We already know the radius is 5, and we have the angle theta, which is 0.7. So L equal to 5 times 0.7. Whatever I get is going to give me this length of this arc. If I want to find the area of this pizza arc, this one, I want to find the area of this, use the formula A equal to half r square theta, in which we will do A equal to half, r is given already 5, and theta is again 0.7, and we will put this in the calculator. We will get A equal to whatever the answer is on the calculator, and that's it for circles. And that's basically everything we need to know about trigonometry. So we go here. This figure 3 shows a design for a sign and a bird sanctuary. Now the design consists of a kite, OABC joined to sector OCXA, of a circle center O. Now in the design, OA equal to OC, AB equal to CB, OAB equal to 2 radians, and let's okay, let's not rush. Let's write this stuff down. OA, which is this radius, because from the center to circumference, OA equal to 0.6, and we know that OA equal to OC. So OA is equal to OC. This is OC, and this is also 0.6, because they're equal. And it says angle OAB, which is OAB, which is this one, it's going to be 2 radians. And angle AOC, which is AOC, which is this one, is theta. Now let's show that theta equal to 1.64 radians, 3 significant figures. So, by the way, if this is 2, this is also 2, by the way, they're equal. But you understand one thing. You understand that angle, it says here, angle OAB equal to OCB, which is this one, OCB, OAB. This is 2, this is 2. By the way, just be careful when it says, for example, angle OCB, it's always the angle at the letter in the middle. So it's the angle at C. So you see 2 radians at C. OAB, angle at OAB equal 2 radians. That means angle at the letter in the middle, which is A. See? This is how to use your brain in trigonometry. Now what you need to do is we need to prove that this angle is equal to 1.64 radians to 3 significant figures. So first of all, the first thing you need to do is you need to cut this thing into 2 triangles. So now we actually have some stuff to work with. See, now we have 2 triangles. We have this triangle and we have this triangle. Okay? Okay, that's good. We have 2 triangles, and we need to find this side. Okay, we have 2 triangles, and I have to find this side. Now, the question is how to find this side. So we know we have angle OA and OC. We have them as sides. We have angle AB. Oh no, AB is already also given us AB. AB is 1.4. And AB equal to CB. So AB equal to CB, which is 1.4. So this is also 1.4. So we have this side, we have this side, and we have this side. Now, as you can see, if we look at the thing carefully, if we look at our stuff carefully, we can see that we need to find, this is our target. By the way, if we split this thing into 2, that means we split the angle into 2. So now we have 2 parts. This is basically half, and this is the second half. So if we find this part, we can just multiply it by 2, and we'll get the whole angle here. Okay, so if we look closely into the matter, if we look using our eyes, we can see that yeah, we can see that شسمونه. We can see that we have this angle, we have this side, we have this side, and we have the angle in between them. Okay, we cannot use the cosine rule because we cannot use the cosine rule, not yet at least. I'll tell you when we can use it. Okay, so the whole plan here is first thing we need to do is because trigonometry requires a lot of thinking. It's like architecture. We need to think of what we will do. We need to plan out our strategy. First thing we need to do is we know that we have these two sides and the angle. So these two sides, the angle in between them. That means we want to find this side in here. So we can find this long line. To find this long line, again, this is a non-right angle triangle because it does not say a right angle. To find this using these two sides and the angle between them, we would use the a square equal b square plus c square minus 2bc cos of a. Okay, now we can find a square. We can do that easily. So a equal, I'm gonna root both sides because I want to remove the square. So b is going to be 0.6 squared plus, here with a, b is 1.4, so 1.4 squared minus 2, b is 0.6, c is 1.4, and cos a, the angle in between, which is 2 radians. So we're gonna write 2. And make sure your calculator is in radian mode, because if it's in degree mode, you'll get wrong answer. So let's put this in the calculator. 0.6 squared root of 0.6 squared plus b squared plus c squared for 1.4 squared minus 2 0.6 1.4 cos of 2. So as you can see, let me just put this in the calculator, hold up. Yeah, I'm so... Okay, so we got the answer 1.7375. Okay, so whatever answer we get, we have to make sure we write the whole thing without rounding, by the way. Until the last final answer, we only round. So 1.7375 6 3 4 3 3. So this is our side. Okay, so this side is let's say 1.73. Okay, 1.73, and this is 1.73. So now we can also, we have the idea. So the second thing is our goal, our objective is to find this angle. So now we can actually find the angle. What we can do is we can use, since we have the side here and the opposite, and we also have the side here and the opposite. So we can use what a over sine a equal to b over sine b equal to c over sine c, which is our sine rule. So sine rule is going to be a over sine a, or not b, I'm not done with this question. Okay, so we're going to say a over sine a, always the capital letter for angle and small letter for side, c over sine c. Yeah, so a over sine a equals to b over sine b equals c over sine c. Now we know that if we look at the letters don't really matter here. We just need to see that we have an angle. We have a side which is 1.73 over sine a. Sine a is the angle opposite, which is 2. So sine 2. See opposite here. 1.73 opposite is 2. So sine 1 over sine 70 over sine 2 equal. We look here, we look at, now to find this angle we need the side opposite, which is 1.4, so we can say 1.4 over x, because we don't know what the angle here is, but we want to find it. We do know, but it's given, but we have to prove it. Here to find x, sorry, it's sine x, has to be sine. Now to find this, we're just going to cross multiply, so just cross multiplication, or to make it easier, No, let's just take this step by step. So we cross multiply this with this with this. So it's going to be 1.73 sine x equal to 1.4 times sine 2. Okay, then we just divide both sides by 173. So sine x equal to 1.4 times sine 2 over 1.73. And to find x, we need to find sine inverse. So sine inverse, or arc sine, 1.4 times sine 2 over 1.73. And we said that this angle okay, let's get this one first. Let's find this one first. So to find this angle, by the way, this 1.73, you're going to write out the whole of this, not just 1.73. This 1.73 I use only to shorten it, but you have to write the whole thing, the whole number, 1.737563450, the whole thing. Okay, so to find now, okay, let me just do my calculation. Okay, so we get x equal 0.8221994335. Now this part we got this angle, but you can see this twice. Because we split this into two parts, that means the angle also got split. So to find the whole angle, we multiply this by 2. So times 2 is going to be x equal to 1.644, and it says here, what is it? 1.64 to 3 significant figures. If we round this up to 3 significant figures, 1.64. Yeah, we got it right. So let me just, we have to write the whole thing though first. 1.64439 886.7, or 1.64 to 3 significant figures, and that is our final working answer. I have to make sure we show every single thing of our working. Our working has to be shown fully, يعني non-stop. Okay. Yeah. Even like all the annotations I'm doing, everything has to be shown fully. Okay, so that's done now. So we go to B now. B, by the way, trigonometry is basically the thing that takes the longest amount of time because it requires a lot of thinking. We know that. Let's first remove this now. We don't need this boundary anymore. But we can keep this one though. We can say 1.64. Okay, so find the perimeter of the sine. Perimeter is basically everything that is on the outside, all the lengths from the outside, we add them. Outside meaning this part, and this part. Okay, the good thing is we already have this part and this part, but we do not have this part. Okay, so to find this part, this outside part, what we need to do is we need to find, first of all, the angle, this one, that's facing it, and then we can use L equal to R theta to find this thing. Okay, very simple. We can do, first of all, because a 360 degrees in radians is 2 pi, and we know a full circle is 360 degrees, which is 2 pi. So to find this, I can just do 2 pi minus this angle, which is 1.644 whatever. So 2 pi, first thing to do is 2 pi minus 1.64439, make sure not to round, 8867. So I can do that. 2 pi minus this will give us 4.638678644. Okay, this is our answer, 4.63878644. Okay, so this is our answer for first, for the angle, the 4.6 something radians. Now again, since we have the angle here, which is 4.6, which is facing the sector, we can just do L equal to r theta to find this thing. Radius is already given 0.6 here, this one, and we can just use our magic formula to get the answer. So L equal to r theta. L equal r theta, and so L equal to r, which is 0.6, and multiply that with 4.6 dot dot dot, which is this whole thing, and I will get the answer. 2 point, and it wants to answer to how much? 2 significant figures, so it's 2.8 if I round it. That's the answer. 2.8. Okay, so 2.8 is our answer, and that's it. Straightforward. Okay. Now last thing is to find the area of the sine. 2 meters squared, 2 squared. Also, it's 4 marks, but it's very easy. Again, we'll go back to our splitting of a triangle. We find the area of this, we find the area of this, and we find the area of this, and we add them. How to find area of A1? A1 and A2 have the same thing. They have the same area because I just split this into half. So I can find this triangle area multiplied by 2, and then I add this area also. Area of a not right angle triangle, we said, is area equal to half AB sine C. So let's just write this down. Area equal half AB sine C. A1, let's say, or area triangle. That's why area triangle equal half AB sine C. So area triangle equal half. We know that A is going to be this, and B is this, and the angle in between them is going to be sine C. So 0.6, 1.4, and sine 2. So 0.6, 1.4, sine 2 is going to be our answer. What's going to be our answer? Half 0.6, 1.4, sine 2 is going to be whatever this is. 0.3819049. 19049,193. So this is the area of a triangle. The triangle. Okay, area of a triangle is this one, and yeah. Make sure you have the calculator on radian mode so it doesn't give you some stupid value again, because the values are given on radians. Okay, anyway, we find this area and we know we have 2 of these triangles, so I'm just gonna multiply the area by 2 because I'm not gonna do the same thing again. So AT times 2 equal, which is basically the answer we just got, times 2, and we're going to get 0.76380983885. Okay, and this is meter squared. So now we will have to find the area of the sector, which is half r square theta. Half r square theta. Half r square theta is going to be, okay, so I told you the angle facing the arc and the radius. We have that already. The angle facing the arc, we already calculated it earlier, which is this 2 pi minus 1.64. We already did it here. So we can just do area equal to half 0.6 squared, and theta is going to be the 4.6. I can't remember the values up here, but just make sure to copy the entire value in, and we're gonna get the answer. We just put this in the calculator. Hold up. 1 over 2, 0.6 squared, 4.6. It's going, no, not 4.6, sorry. 2. 64439. Okay, and the answer is going to be 0.8 area sector, because 0.8349815592. Okay, so to find the area of the total thingy, you're gonna add the area of the sector plus the area of the 2 triangles. So the area of the 2 triangles which we found and the area of the sector, which is this thing. So we're just going to add them. We found the area of the two triangles after multiplying by 2, which is this one. We found the area of the sector, which is this one. So area total equal, just add them together. So this answer plus 0.78630809, not times, plus 8385, and the answer is going to be, it wants the answer in 2 significant figures, so 1.6 meters squared, and this is the answer. It was quite a long one, wallah. It took me it took me a little time to solve this question. It took me a while, but alhamdulillah, it's done. Okay, so this is a trigonometry question. It's quite difficult, it requires thinking, but once you solve a lot of them, it becomes easy. Okay, so we have this question 8. Oh my god, 2 5-mark questions. Oh my god. Okay, and then we have question 9, and we have question 10. So, okay, 10 is pretty easy. And, okay, it's fine. This is all easy stuff that's left. So, it should be good. Okay, so question 8 tells us figure 4 shows a sketch of curve. This is a curve equation, quadratic. Okay, so the point M is the maximum point on C, and we have to write this equation in the form A plus B x minus x plus C squared. Okay, any time it wants us to write in this form, we're going to use something called complete the square. Completing square. Okay, I don't know why I wrote that. But completing the square, thing about it is, it has a formula. Completing square formula is x plus b over 2 squared minus b divided by 2 squared. This is like a memorizing formula. You have to memorize this, like it has to be done. But now there's a condition. I'll show you what I mean. Okay, so we look at this and we have to write it in this format. We take and we rearrange this so that the x squared, like it's in this form, ax squared plus bx plus c, so the x squared is in the front. So I just write minus 3x squared plus 12x plus 4. Same thing. It's the same equation, except I bring this and I put it here, and I bring this, I put it here. That's it. Same equation, nothing changed. Now, if I want to complete the square, this x has to be 1, but here it is minus 3, which is not something I want. So what I'm going to do is, since minus 3 and 12, minus 3 is a factor of 12, I'm going to factor minus 3 out, and I'm going to factor it out, and I do x squared, and I can't put plus 4x, because that's going to, minus times plus is minus, and here it's plus, so I have to put minus 4x, because minus 3 times minus 4 is going to be plus 12x, so I have to think outside the box, Okay, now that we factored it out, we're going to take this part and we're going to use this formula. So x squared minus 4x equal, use this formula, x, this is b, by the way, this is b, and yeah, this number is b. So plus b divided by 2, but it's minus 4, so minus b divided by 2 is minus 4 divided by 2 is minus 2, so x minus 2 squared minus b divided by 2 is 4 divided by 2, minus 4 divided by 2 is minus 2, minus 2 squared is positive 2, so I'm just going to write 2. X minus 2, yeah, x minus 2 squared minus 2. Okay, so we're just going to, now what we're going to do is we're going to put this instead of that. Instead of this, we're going to replace it with the new thing. We have now. So minus 3, big bracket, x minus 2 squared minus 2 plus 4, and we expand. So it's going to be minus 3. We can't expand this, so we're just going to write it like this. Squared. Minus 3 times minus 2 is plus 6. And minus 3 times minus 2 is plus 6. And plus 6 times 4 is plus 10. So this is our answer. Or, because it's once in the format, I can also write this as 10 minus 3x minus 2 squared. Now, I want to check the answer is correct or not. I'll show an actually interesting way that no one really talks about. Interesting way to check if the answer is correct is, okay, so the whole point of completing the square is to find a maximum or minimum point. To find the maximum minimum point from what I have here is to flip the sign here and use this coordinate as the y coordinate. So it's going to be minus 2, flip it, it's going to be 2. That's the x coordinate. And this, without flipping any sign, is the y coordinate. So the coordinates of the maximum point is positive 2 and 10. Now, okay, so let's say I'm very sharp jabti and I don't think it's correct. What I'll do is I'll take this equation and I'll do dy by dx to it, which it will give me 12. I already told the rule, so I don't think I need to say it again. 12 minus 6x, because I multiply 2 times minus 3 is minus 6 and 2 minus 1 is x power 1. So 12 minus 6x, and I want to find the, so I do 12 minus 6x and then I want to make it equal to 0. And then I take the 6x to the other side, so 12 equals 6x and x on its own, so 12 divided by 6 is going to be 2. So as you can see here, the x coordinate is also positive 2 because I flipped the sign. So as the method worked. And 10, if I want to check it, well, if I want to check the 10, then I just substitute 2 into this equation and I check if that gives me 10. So if I substitute 2 into the equation, 4 plus 12, 2 minus 3, 2 squared, that will give me that will it should give me, oh, unless I made a mistake, hold on. No, yeah. Okay, just slight mistake I made. Instead of 10, it should be 16. Tell you why. When I did this here, I didn't square the 2. So it should be 4. Yeah, there you go. And this has to be 4, it'll be 12, and it'll give me 16. So that's it. If that's the only thing I had mistaken, don't kill me for it. Same thing, minus 3 times minus 4 is 12, 12 plus 4 is 16. Yeah, that's it. So 16 minus 3x minus 2 squared. Okay, so we wrote it in the format. And hence, otherwise state the coordinates of m. I already told you how. Flip this and use this as it is. So m is equal to minus 2, flip it. It's 2 and 16 as it is. Okay. So yeah. That's it for m. And then we have to find, it says the 9L1. 9L1 passes through O, which is origin 0, 0, and m. And we already have the coordinates of m, 2, 16. And we need to find, it says the line L1 passes to over m, the line L2 touches C, so it touches C here, and it's parallel to L1, and find the equation for L2. Now this is a very, 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 very difficult question, and even me when I first did it, it was very hard for me to solve, because of one concept. It was easy, but it was unclear. Okay, let's start off. This says find an equation for L2. Now it says L1 passes through O and M. That means let's find L1 first, because we have 2 points for L1. L1, which is the line you see on the screen, this line, it passes through 0, 0, which is the origin, and it passes through M, which is 2, 16. So we can find, and we know the line is a y equal mx plus c line. So we can just do, which is this B, yeah? Or C, I don't know, B or C, it's B. Yeah, so we're going to find the gradient. Gradient is equal to y2 minus y1 over x2 minus x1. And we have so our 2 points is going to be 2, 16, which is x2, y2, and 0, 0, which is x1, y1. I don't need this anymore, because anything minus 0 is 0, so I'll do 16 minus 0 over 2 minus 0, which will give me 8. Gradient is 8. Okay, so y equal to xx plus c. No, not 8x plus c actually, because c, the y-intercept is 0, because you can see the L1 is crossing through 0, and the y-intercept is where it crosses the y-axis, and it crosses the y-axis at 0. So I don't need to write anything for the y-intercept. I can just write plus 0 or nothing, because that's nothing. So y, it goes to 8x. Now, the difficult part is that it says line L2 touches C and is parallel to L1. Find the equation for L2. So we need to kind of analyze the situation. So we know that line L2 has parallel. Parallel means same gradient, so y is equal to 8x plus c. But see, the issue here is I don't have c and I can't find c because there's no information on which point L2 touches. But it does say it touches c. Touches c means touches one time. Means that it touches c, like it can touch it like this, it can touch it like this, but as long as it touches only once. Okay, so if it touches C once, okay, so if any line touches another line twice, we know that there is two real solutions, and it's b squared minus 4ac will be greater than 0. If it touches one time, like I mentioned now, b squared minus 4ac is equal to 0. And if it touches no times, then it's b squared minus 4ac is going to be less than 0. In this case, we touch once, so we're going to use equal to 0. The line touches C once, so it touches the graph C once, curve C once, and we need to find C. So to find C here, we're going to, first of all, we know that they touch each other. C, the line L2 and C, we don't know L2 yet, but I'm gonna guess L2 something like this. No, L2 is parallel, it can't be like that. L2 maybe something like this, maybe. Or maybe, it can be anywhere. So yeah. L2 looks like that. So let's assume that, not assume, we can't assume anything, but we know that they intersect. So this line L2 intersects with C, so I have to make them equal to each other. So 8x plus C, which is C is a number, the y-intercept we don't know, equal to minus 3x squared, which is C. C is minus 3x squared plus 12x plus 4. Okay, so one thing we need to do now is we need to make them all to one side. I'm going to take everything to this side because I want this to be positive, the x squared. So I'm going to take all to this side, so it's going to be 3x squared. It's going to be 8x minus 12, 8 minus 12, 4 minus 4x. Because plus becomes minus, so 8 minus 12, 8x minus 12x is minus 4x. And this becomes minus 4 because plus 4 becomes minus 4 when I take it to the other side. And plus c equals 0. Okay, so we said b squared minus 4ac is equal to 0. So let's go. B squared minus 4ac equals 0. We can say b is going to be this, and c is going to be all of this, because this is any number, it can be a number, so it's a constant. So we can take this c, this is b, and this is a. So b squared, which is minus 4 squared, minus 4a, which is 3, and c, which is minus 4 plus c. Minus 4 squared is going to be 16. Yeah, minus 4 times 3 is 12. Equal to 0. Okay, so minus 4 minus 12 times minus 4, so minus 12 times minus 4 is minus 48. So 16 plus 48, and minus 12 times c is minus 12c equals 0. Minus 12c I can take to the other side, so 16 plus 48, let's do that first. 16 plus 48 is going to give 64 equal to 12c, because negative 12c becomes positive if I take it to the other side. So c equal to 64, let's do 64 divided by 12, and that is 16 over 3. 64 over 12, 16 over 3. And the answer is 16 over 3. Now the c here is the c in this. You see where we have the L2, where we said it was y equal 8x plus c? Well, yes, L2 has the equation y equal 8x plus c, and we already found c, c is 16 over 3, so we can write 16 over 3, and this is our answer for L2. And this is kind of a complex question, because it requires really out of the box thinking. No, it's very hard for someone to come up with, oh, b squared minus 4ac is equal to 0, because this is an unusual case. But it's all the time, if that's the only thing you can think of, it's most likely the correct answer, the correct way of solving. That's question 8 done. Question 9. Question 9 is pretty simple. It's basically just sketching graphs. So I'm going to do it quickly so I can move on because it's getting late. So it says here, figure 1 shows a sketch of the curved equation y equal to fx where root x, fx equal to root x. The point 93, which is p, and the point 0.93 lies on the curve and shown on figure 5. The next page, it is a copy of figure 5 called diagram 1. So this is diagram 1. And on the diagram 1, sketch these two. So we have y equal to f of 2x. So y equal to f of 2x. Let's sketch this one first. I told you when we have in the bracket, we're going to find the reciprocal. This is a stretch. So we're going to find the reciprocal of 2, which is 1 over 2, and multiply the x coordinates by that. So basically, this would be like a shrinked graph. So p, I need to multiply by 1 by 2. 9. So if all the x coordinates of the graph, I have to multiply by 1 by 2. The only x coordinate I have, which is this one. 9 times 1 by 2 is gonna be 9 divided by 9 times 1 by 2. It's 4 9 divided by 2, so 4.5. So I'm just gonna draw something like this. This is how it's gonna look like, and the point P will be at the same height, but it's going to be a half. So it's going to be 9 by 2, 3. Just the x-coordinate changes, because we're just shrinking the graph. So multiply x-coordinate by 2 and draw it. It is 9 by 2, 9 by 2, 3. Okay, so now we have the second one, which is fx plus 3. Now since the thing is outside the bracket, that means the change is happening in y. So I'm going to add 3 to y. So as you can see, well, if I'm adding 3, that means the graph is going to start from here, from 3, not from 0, because I'm adding 3 to every y coordinate. And p would be same, 9, but 3 will add 3, so it would be 9, 6, since we're adding 3 to the y coordinates. It looks something like this, where p is the same, x coordinate 9, but it adds 3. So this is the two graphs. Basically very simple to do and very nice and easy. Y at f of 2x, stretch, take the reciprocal, multiply by the x value here. It's because outside the bracket, add 3 to y. So basically the whole same graph, but all the y coordinates are added 3. Okay, so that's question 9 almost done. We still have a part left. See here, show that the x coordinate of q is a solution of this. Okay, so x coordinate of q is a solution of this. First of all, we need to understand that the graph y equal to f of 2x, which is the one we drew here, and y equal to fx plus 3, which is the second. So these two graphs that we just drew, they're eventually going to intersect like this. Okay, they're going to say, that's a very horrible drawing, but they're going to intersect. Okay, so at the point Q. Now show that the x-coordinate of the point Q, which in that intersect, is a solution of this. Okay, so what we need to do all the time when two points intersect, we equate them. Y equal to f of 2 of x. Basically, I can substitute what's in the bracket of, because this is f of x. So f of 2 of x will just be me replacing x with 2x. So f of 2x, since f of x equal to root x, whatever in the bracket is going to be here. So it's going to be, if it's f of 2x, it's going to be root 2x. So it's going to be root 2x, and f of x plus 3 means root x plus 3, equal to root x plus 3. Okay, first thing I'm going to do is take like terms, same side. So root x is going to come here, because these two are like terms. So root 2x minus root x equal 3. Factorize. Root x bracket 2. Oh, sorry, root 2. Because I'm basically factorizing. Root 2 minus 1 equal 3. And to get root x on its own, I'm going to divide both sides by this, because since these are multiplying, this is multiplying with this and this is multiplying with this, I want the opposite, which is divide, because I want root x on its own. So I'll divide both sides by root 2 minus 1, and we're going to get root x is equal to 3 divided by root 2 minus 1. But as you can see, this is not the same as what we have here. I'll tell you why. Because we have to rationalize the denominator. Meaning, rationalize means I will take this and I will multiply both up and down with the same equation but the opposite sign. Multiply up and down with it. Okay, using the calculator, if I multiply this with this, it's going to give 1. So I خلاص, because 1 is the denominator, then it's basically like there's nothing. So root x equal, and if I multiply this with this, as you can see here, 3 bracket root 2 plus 1, 3 bracket root 2 plus 1, because I'm multiplying with these two. So this is we got it. This 2, when I multiply them with a calculator, if you use a calculator and multiply them, you're going to get 1. So it's basically me writing this, which is the same as just without 1. So this is our answer. Now it says C. Let's go down to C. And we know root x equal to 3 root 2 plus 1. Now it says find the coordinates of Q. This was to show that root x equal to this. Now actually find the coordinates of Q. Okay, to find the coordinates of Q, just basically find x, just remove the root. By removing the root, you basically square both sides, because it's the opposite. Squaring both sides. Okay? So, if I square both sides, then it will be x equal to 3 squared is 9. And we're going to have root 2 plus 1 squared also. Root 2 plus 1 squared, if we find that, and let's just put in the calculator. Or if I put all this in the calculator, aslan, I don't need to expand or anything. I can just put all this in the calculator, and we get the answer. Well, we can aslan write this as the answer, but better not. But basically, you just put this into the calculator and you get the answer. If you plug this into the calculator, we're basically getting. We can write like just put 9 bracket 3 plus 2 root 2. Yeah, because root 2 plus 1 squared is this, so I can just write it like this, no problem. This is the x coordinate, and to find the y coordinate, I'm going to substitute this into the original equation, which is root x. So I can substitute 9 2, substitute that into root x, so root answer root x, substitute it to root x, because f of x equal to root x. So just substitute as, because this is our x coordinate, so just substitute this as x. So root 9 3 plus 2 root 2 it will give 3. Let me just do this. So root of 3 plus 2, 3 bracket root 3 so after that, you just plug into the calculator, you get 3 root 2. After all this in the calculator, plus 6, which is the answer. After everything in the calculator. And 3 root 2 plus 6 is the answer. And that's question 9 done. Okay. So since that's done, we have last question. So, Creva's equation, fy equal fx. It says given that f dash x basically means dy by dx of f of x. So the differentiated equation of f of x is f dash x. F double dash x is dy by dx of f dash x. So it's the second derivative we call. Now it says here f dash x equal ax minus 12x power 1 over 3. Where x is a constant, and f double dash x equals 0 when x equal to 27. Curve passes to the point 1,8. Okay, so we need to find the value of a. Find the value of a. It says f double dash x equal to 0 when x equal to 27, and we have f dash x but a. But basically what we need to do is we need to find f double dash x. F double dash x is basically finding the dy by dx of this x minus 12x power 1 over 3. And you already know the rule. So any number, a can be any number in the world. And since x is to the power 1, I can just remove the x and just put a. And I need to multiply 1 over 3 times minus 12 is going to give minus 4 x, and 1 over 3 minus 1 is minus 2 over 3. Again, the rule is, if you forgot, 1 over 3 times minus 12, and we need to minus 1 from here as well. So after that you get this. Okay, so now it says f double dash x equal to 0 when x equal to 27. So basically this equation, when x is 27 and I substitute 27, then the whole thing equal to 0. So I'm just going to put this in the calculator now. 27 to power minus 4, 27 power minus 2 over 3. We get minus 4 over 9, so a equal to, so a minus 4 over 9 equals 0. Take the 4 over 9 other side, a equal to positive 4 over 9. And that's our A answer. Now B is going to be very easy. This is very important, by the way. Now that we have the value of A, we need to understand one thing. Okay, so this is an important concept. We know that when we differentiate an equation, let's say 5x cubed plus 5, the differential of this is 3 times 5 is 15, x squared, and the plus 5 is gone. So we get 15x squared. But also, if I told you if the plus 5 wasn't even there in the first place, the differentiated equation would be the same thing, yeah? That's why always when we're integrating, we have a plus c. Because first of all, you need to understand that integration is basically the reverse of dy by dx. We're reversing the actions of dy by dx. So if f dash x is, if you want to get f of x of the f dash x, we need to integrate f dash x. Because f dash x is basically dy by dx. So we integrate f dash x in respect to x. So we integrate f dash x. Integrating f dash x, we already have f dash x, and we found the value of a, which is 4 over 9. So let's rewrite f dash x equal 4 over 9x minus 12x power 1 over 3. Okay, so now to find the integral, to find the f of x, this wants us to find f of x. To find f of x is equal to the integrand, whatever you want to call this, of f dash x, which is equal to the integral dx, make sure to write dx, of 4 over 9 x minus 12x power 1 over 3. Okay, let's just integrate. So we already know the rule, x power n. The rule is x power n plus 1 over n plus 1. So let's integrate. So if we integrate, it's going to be, I told you, 4 over 9. When there's a fraction, just put it there and then put a multiplication sign, which is dot. Then the x, you take action on the x only. X power 1, we add 1. It's x power 2 divided by 2. Minus 12. X power 1 over 3, we add 1. X power 4 over 3. Just put the calculator, it's okay. Okay, then now we just use calculator to just simplify everything. So simplify this. 9 times 2 is 18. 4 over 18 is 2 over 9. So just put this in the calculator. 4 times 4x squared. 9 times 2 is 4 over 18. 4 over 18 is 2 by 9. 2 by 9 x squared. Just let's simplify, because I'm multiplying this with this and I'm multiplying this with this. 9 times 2 is 18, and we're going to get 4 by 18. 4 over 18, if we simplify, we get 2 by 9. Simplify means divide the both, because if we divide 4 by 2, we get 2, and divide 18 by 2, we get 9. And the x squared stays where it is. Minus 2 divided, minus 12 divided by 4 by 3. going to give us minus 9. So minus 12 divided by 4 by 3 is minus 9 x power 4 over, make sure to put the plus c, plus c equal to f of x. Now, how to get c? Simple. We will take the point that it gave us and substitute. 1 is the x coordinate, minus 8 is the y coordinate. F of x is basically y. So I can substitute 2 by 9, 1 squared minus 9, 1 power 4 over 3, plus c equal to minus 8. And then I can substitute. So let's put the substitution. Okay, minus 39. So minus 8 plus. So we get 7 by 9. So c equal to 7 by 9. And we're just going to rewrite this equation, the same one, but the plus c we will write as 7 by 9 because we found c is 7 by 9. So 2 over 9 x squared minus 9 x power 4 over 3 plus 7 by 9 equal to f of x. This is our answer, and this is the last question of the paper. Thank you for watching. I mean, I don't know, it took me so long, but hopefully it's helpful.